Okay, so let's pick up the lesson here. We know that the octet rule states that an element is trying to fill that outer shell of electrons, where it's 8 electrons in the outer shell, because that full valence shell is actually very stable. You can do this by giving or taking electrons. Metals give electrons and nonmetals take them. If you have gained or lost an electron, you are now called an ion. Okay, so an ion is basically when an atom just gains an electron, it becomes negatively charged. We call that an anion. I like to remember that by saying a negative ion. Nonmetals gain electrons. When a nonmetal gains an electron, it is positive. So I like to think about like cats are positive, like cat paws, just to help me remember which one is positive, which one's negative. So here you go. So a negative ion and then a cation. You can also do it this way if you think about the T as being a positive charge. That can help you to remember that a cation is positive. Okay, cations are always smaller than the original atom, and the reason why is that when you are losing those electrons, you're actually going to work to lose that entire outer shell. So your size is now dependent upon the shell that was underneath it. When you are an anion, anions are always larger than the original atom, and that's because we're now adding electrons to that shell. Right, so here's what it looks like when you are lithium as a cation, smaller, and then lithium as a regular atom, larger. The opposite is true here. Notice oxygen is originally smaller, and then once you have added those 2 electrons to that outer shell, that it's now larger. So cation formation works like this. I have that 1 valence electron. Notice here I've got just 1 valence electron out there in the outer shell. So this is an atom of sodium. That valence electron is lost. Now, I don't want to say that it vanishes. That electron is going to be picked up elsewhere in the universe. But I want you to think about it in terms of this, that I am now losing that outer shell. Notice now that my radius is a lot smaller. Okay? My effective nuclear charge remains the same, right? That number of protons remains the same on the remaining electrons. So those remaining electrons are then pulled in even closer, right? So now instead of pulling in on 11 electrons, now I'm pulling in on 10 electrons, and I can bring those 10 electrons in closer. In my anion formation, I have an electron, right? That could be the same electron that we lost for sodium. I'm picking it up from somewhere. So I have 7 valence electrons. We know that it's 1 electron away from a full octet, so it's really, really going to want to grab that extra electron. So 1 electron is added to that outer shell. Okay? But because the number of protons remains the same, but the number of electrons has now increased, that electron cloud expands a little bit. Just because I don't have as much pulling on that shell. So here's my chloride ion. So here's sort of your exit ticket, or just a way to sort of check. You won't need a grade cam sheet because we don't have grade cam. But here are some questions for you to go through. Elements in the same group or family have the same number of blank. And the answer is valence electrons. As you are going down a group, it is defined, really, or its properties are defined by the number of valence electrons. Question 2. Elements in the same period have the same number of what? That is energy levels. If you're in the same period, that means that you're in the same row. So all of my 3rd row elements have 3 energy levels. Select the atom with the largest atomic radius. You can look at that on your periodic table. And it's whichever one is closest to francium. Ionization energy is the energy required to do what? Go back and look at your notes. And then, which of the following elements has the highest ionization energy? Remember, it will be whichever one is closest to helium. Question 6. Which element on the periodic table has the highest value for electronegativity? This element I actually want you to know. You should know that fluorine has the highest electronegativity. Okay, that's it for today's lesson. You should be prepared for the lab tomorrow. It's a really easy lab. Don't try and make it more complicated than it is.